Identify the constant variable between both trials. In both trials, exactly 5.0 grams of the solid solvent H4ClO4 is dissolved in water. Since the chemical process and the mass of the reactant are identical, the total amount of heat absorbed during the dissolution, Q, must be identical in both calorimeters. Recall the calorimetry heat equation. The heat exchanged by the solution is given by Q equals m times C times delta T, where m is the mass of the solution. C is the specific heat capacity of the solution, which is approximately equal to that of pure water for 0.18 J/G degrees Celsius, and delta T is the temperature change. Because the density of water is 1.0 grams/ml, the mass of the solvent dominates the solution mass. First calorimeter, 100 ml, approximately 100 g of water. Second calorimeter, 1000 ml, approximately 1000 g of water. Establish the relationship between mass and temperature change. Since the heat absorbed, Q, and specific heat capacity, C, are constant, the temperature change is inversely proportional to the mass of the water. M1 times delta T1 equals M2 times delta T2. Calculate the new temperature change. Delta T2, the volume, and therefore mass, of the water has increased by a factor of 10, from 100 ml to 1000 ml. Because there is 10 times as much water to absorb the same quantity of heat, the magnitude of the temperature change must be 10 times smaller. Delta T2 equals delta T1 over 10 is equal to minus 3.0 degrees Celsius over 10 is equal to minus 0.3 degrees Celsius. Determine the final temperature. Since the dissolution of ammonium perchlorate is endothermic, indicated by a temperature decrease, the temperature of the water will drop by 0.3 degrees Celsius from its starting temperature of 25.0 degrees Celsius. T final equals T initial plus delta T2 is equal to 25.0 degrees Celsius. 0.3 degrees Celsius equals 24.7 degrees Celsius. This aligns perfectly with option B. The correct answer is option B, 24.7 degrees Celsius.